Welcome to Pavonars, webinars for the pavement community. Today we'll be talking about exploring the influence of pavement preservation, maintenance, and rehabilitation on Arkansas's highway network. And this is an educational case study. I do want to highlight that you'll see on the following slides many pictures of pavement maintenance treatments that are being applied to a roadway that leads toward preservation. And you can see this first picture is the asphalt emulsion being sprayed for a chip seal. This presentation is based on what I call side projects, and Logan Kiihnl helped me with this side project during his first semester of graduate school. And he and I wrote the paper titled Exploring the Influence of Pavement Preservation, Maintenance, and Rehabilitation on Arkansas's Highway Network. And it's an educational case study because we actually used the fall 2018 CVEG 4423 Transportation Infrastructure class in order to collect a lot of this data and understand some of the trends that you're going to hear about. Logan graduated with his Bachelor of Science from the University of Arkansas in Civil Engineering in 2018, and he completed his Master's with me in Civil Engineering in 2020. And you can see his LinkedIn profile here on the screen, and it's also in the section below, in the description below. So let's start with the general definition of pavement preservation, and I'm going to turn to the FHWA, or the Federal Highway Administration. And a term that I am very familiar with is from the 1990s. And the terminology was pavement preservation was the right treatment on the right road at the right time. So it's a tripod. You need to think about what treatment are we placing, what road are we going to place it on, and what condition of the road is that in. In 2016, through the Everyday Count, or EDC initiative, they pivoted a little to discussing more of whole life investments and the management of the entire pavement network. And this is through EDC4. And the purpose of EDC4, or Everyday Counts, was to support preserving highway investments by managing transportation pavements proactively. And instead of focusing on the right treatment on the right road at the right time, they kind of pivoted toward the concept of when you apply a treatment, where you apply a treatment, and how you apply a treatment. So they bring in proper construction practices as well. Now, whether you're looking at the 1990s definition or the 2016 definition from FHWA, they're kind of both circulating around this same theme of keeping roads that are in good condition and maintaining them to stay in good condition. And why are we interested in doing this? Well, taking a look at the very big picture, in 2017, it was estimated by the Bureau of Transportation Statistics that all of the U.S. highways and streets put together were worth about $3.6 trillion. So we have an incredibly high value infrastructure investment in place, and I believe it's in our best interest to take care of that investment. And so the research objective for this paper was to explore from an academic perspective, and that's a key point, which you'll find out soon, the influence of pavement preservation, maintenance, and rehabilitation treatments for flexible pavements on a state highway network. And as I mentioned, this was done using the class CVEG 4423 in the fall of 2018. I call it the PPRA project, and that stands for Pavement Preservation and Recycling Alliance. And if you go to the website roadresource.org, that was actually put together by PPRA, hence the name PPRA project. Now, if you look back in literature, there are literally hundreds of articles available on pavement preservation, on pavement maintenance, and on pavement rehabilitation. So just a very quick overview, there's multiple universities that have looked at this, including but not exclusively Nevada, Reno, Iowa State, Rowan, Texas State, and Georgia Tech. Also, NCAT, the National Center of Asphalt Technology, has done a lot of research on this, and they have a very nice website on it right now, if you go check that out. And then obviously multiple DOTs have done research as well. One of the challenges, though, that I faced when when thinking about this project and thinking about how to develop a classroom project around this is that there are a wide variety of treatments. And if you look at any one single study, very rarely do they look at all of the treatments in a single setting. Now, NCAT has taken a step in that direction, which I really applaud and I'm very excited about, but it's difficult to compare different studies in different locations with different materials, different contractors, all those type of things, because then there's a lot of other factors that need to be taken into account. And to add on to that, when you think about each treatment as an individual treatments, they all have different costs depending on where you are. They all have different lifespans depending on what road you put it on. And they're all sensitive to the environment depending on if you're in a northern climate, a southern climate, a wetter climate, a drier climate. All these things have some impact on the performance of the treatments. And one of the things I like about roadresource.org is it cuts through many of these challenges, which I'll explain on the next slide. So if you haven't already, I encourage you to go to roadresource.org. It is a phenomenal resource, and it's built around 4 calculators where you can calculate the life cycle cost, the equivalent annualized cost, the remaining service life, and the cost benefit value. And while the PPRA project that we performed in class used all 4 of these calculators, this presentation will just hone in on the life cycle cost and the remaining service life. If you're interested in learning about the other 2, I encourage you to take a look at the paper, but I think that these 2 are by far the most impactful calculators that we explored. And roadresource.org has 9 maintenance treatments that we explored in class, and this includes rejuvenating fog seal, crack seal, chip seal, slurry seal, and scrub seal, microsurfacing, both a single layer and a double layer, and then cape seals. Another nice thing about roadresource.org it actually has dedicated pages to each one of these treatments talking about the material selection, the design, the construction, the quality assurance. It has all sorts of information on these treatments as well. So it's a very comprehensive website. In addition to looking at maintenance treatments, we also looked at rehabilitation treatments, cold in place recycling and hot in place recycling, or CIR and HDR, and we put chip seals or overlays on each one of these treatments. And then 2 reconstruction treatments, full depth reclamation, or FDR, and then base stabilization with overlay. Now, these are all the treatments that are showcased on roadresource.org, but we also included a lot of the more typical maintenance and rehabilitation treatments that are used, including mill and fills, overlays, ultra thin bonded overlays, and remove and replace, those type of things. So in addition to these treatments, we also looked at some of the more standard treatments, as we'll cover in future slides. Now, in order to make this come alive, I actually used real data from RDOT. And I think this is very important because when the students are sitting in the classroom, I can talk about, hey, if you drive down I-49 to I-40, you're driving on RDOT's network. This is the actual condition of the roads that we're using. And these are the actual highway types that RDOT has, or the Arkansas Department of Transportation. So I simplified RDOT's network a little bit into 3 different highway types: freeways, multi-lane highways, and 2-lane highways. And you can see this is a challenge that is common to many agencies, where as the highway type, as we go down that list, the lane miles increases significantly from 3,000 to about 4,500 to almost 29,000. But if you look at the traffic, it's an inverse relationship. So freeways by far have the most amount of traffic, and 2-lane highways have by far the least. And this is a very common challenge with agencies. By far the largest number of lane miles tend to have the least amount of traffic. So this is something that's always very interesting to discuss in class and to think about as agencies continue to improve their highway networks. And we also mined RDOT's data for their PCI per highway type. So PCI is Pavement Condition Index, and it's a very nice index. It's A through F. Everyone understands A's are good, F's are bad. And you can see, again, freeways tend to be in very good condition, majority A's and B's. Multi-lane highways is a little more mixed bag. The meat of the network is between B and D. But then 2-lane highways, it's the opposite of freeways. So the largest amount of lane miles is in the worst condition, and it has the least amount of traffic. And this is all 2018 data. So it's getting a little older, but at the time it was brand new. And their pavement preservation, rehabilitation, and reconstruction budget that we used in class was just over $236 million. So as we went through the four calculators, as the students looked at those different treatments, they used this data from RDOT, their highway types and lane miles and traffic, the condition of those highway types, and then the actual budget available to RDOT. So the first calculator we'll talk about is the life cycle cost, and we looked at a 50-year analysis period. And what happened is each group in the class got one maintenance treatment and one rehabilitation treatment. Now, please note that little disclaimer off to the side. This is not realistic. I do not encourage anyone to put one treatment on an entire network. But this is an academic exercise, and the point is to compare maintenance versus rehabilitation. And so you can see here on the y-axis, we have the total costs over a 50-year period of putting these different maintenance treatments on a road. And something that pops out immediately is in the lower left-hand quarter, those have the lowest costs, and it's only either asphalt emulsion or a sealant material. And as you move up to the right, you add aggregate and the chip seals, slurry seals, scrub seals, and microsurfacing. Then cape seals are a combination of a chip seal and a slurry or microsurfacing. And then in the far upper right corner, you have the hot mix asphalt based treatments, the bonded wearing course, the thin lift HMA, and the ultra thin lift HMA. And then as we pivot over to the rehabilitation and reconstruction treatments, all my students would show displeasure that I used a different y-axis. But if you look at where the ultra thin lift HMA is on the left graph, it's just under 25 million. Then if you look at the rehabilitation reconstruction graph, the CIR plus two chip seals pretty much leaves off right where that ultra thin lift HMA is. So this can be kind of seen as a continuous line, where you have the cold in place recycling, then the minor mill and fills, the hot in place recycling, the major mill and fills. Then you get into the reconstruction, the full depth reclamation, the full depth remove and replace, and the base stabilization. So the two main takeaways from these graphs are you have higher costs with more intensive maintenance treatments, so the hot mix based treatments or the treatments with aggregates, and you have higher costs when you do rehabilitation and reconstruction versus maintenance. And I don't think anyone would argue with these numbers. Roadresource.org uses national level cost averages and national level treatment life averages. So these may change based on your region, but in general, these are the trends that people see. More invasive maintenance treatments are more expensive, and rehabilitation and reconstruction is more expensive than maintenance. Now, the second tool we'll look at revolves around remaining service life. And remaining service life has units of lane mile years, and this is quickly becoming one of my favorite units. An example of this is, let's say you have 1 lane mile of road and you don't do anything to it. You don't preserve it, you don't put a maintenance treatment down, you don't put a rehabilitation treatment down. After 1 year, you have a 1 lane mile year loss in your network. Now, let's say you take that 1 lane mile, but you put a 4-year preservation treatment on it. After 1 year, you have a 3 lane mile year gain. And that's because 1 year has passed, but you've invested 4 years into it. Therefore, 4 minus 1 is 3. So this seems relatively straightforward, but as you start looking at entire networks, it obviously becomes very complicated very quickly. But let's take a look at the data for RDOT. So looking at the remaining service life, again, our analysis period is 50 years, and we're putting one treatment on an entire network, which again is not realistic. It's an academic exercise. And you can see here almost the exact opposite relationship as you saw with costs. So looking at the maintenance treatment, now on the y-axis, we have lane mile years. And this is either gained or lost, and it's in the thousands. So the rejuvenating fog seal, which had the lowest cost over 50 years, has by far the highest amount of lane mile years. It's over 110,000 gained lane mile years over a 50-year period. And then you can go down with the crack seals, the fog seals, getting into the surface treatments with aggregate, chip, slurry, scrub, and micro. And then in the lower right-hand corner are the asphalt concrete or hot mix asphalt based treatments. Now, again, looking at the rehabilitation, the reconstruction, you can actually see that only two of these treatments have positive lane mile years. All the rest of them are negative. So not only does maintenance provide higher remaining service life than rehabilitation across the board, but all but two rehabilitation treatments have negative lane mile years. What this means is when you place any of those rehabilitation treatments on a roadway, your entire network is actually decreasing in quality. I know that there are roads out there in bad shape that require rehabilitation and reconstruction. However, if all we do is focus on those roads that require rehabilitation and reconstruction, we're setting ourselves up for failure because our network will continue to lose lane mile years as we continue doing these rehabilitation and reconstruction treatments. I could talk all day about this, and there are probably some of you who know me who have actually heard me talk longer about this. So I'm going to just stop there and I'm going to pivot to student responses. I gave a survey at the end of the class saying, what did you learn? This is coming from senior students after taking the class that included the PPRA project. And you can see here, this coming from a student says, quote, DOT should take the time to evaluate their use of pavement preservation techniques and really analyze the effects that they might have on the current road networks they are maintaining. This could come from a professional who's been in the industry for 20 years, but after one semester, a student was able to catch on to this. Other students, PPRA project was informative. It was a very useful learning tool. It was neat. Pavement preservation, maintenance, and rehabilitation techniques all play a vital role in the treatment of roadway networks. And finally, pavement preservation has the ability to provide direct, cost-saving, and innovative solutions to the varying issues within the 37,000 lane miles of highway network in Arkansas. When I saw these responses, it absolutely blew me away because this meant that the students, over the course of just one semester, were able to start understanding that applying maintenance treatments and preserving our roads is far more effective than reconstructing and rehabilitating our roads. And trying to pivot this mindset is, I think, very important moving forward. So in conclusion, Logan and I utilized CVEG 4423 transportation infrastructure, where we had 61 students divided into multiple groups. And these groups explored the four calculators on roadresource.org using RDOT's network. They explored the lifecycle cost, the equivalent annualized cost, the remaining service life, and the cost benefit value. For this presentation, we just focused on two, but the paper has all four. The biggest takeaways in my mind were that non-standard maintenance and rehabilitation treatments save costs. For example, rejuvenating fog seals, you have over 110,000 lane miles gained over the 50-year period. And then treatments like cold in place, which is not used a whole lot in the state of Arkansas, plus chip seals, you actually are improving your network overall. And the biggest takeaway in my mind is preservation and maintenance is better than rehabilitation and reconstruction. So if you are interested in learning more, you can read the full paper. This is the full citation. You can also click on the DOI link, which is um, in the section below, the description section below. And I thank you for taking the time. I hope you found this informative, and I hope you have a wonderful day.